So what we're continuing on with today is systems. These systems of three variable equations. Now, whenever we solve these here, the first thing we want to do is eliminate one of the three variables out first to give us two equations with two variables, and then eliminate another variable to get one equation with one variable and solve backwards. Now, if we look at this one here, when we pick a variable to eliminate first, well, actually all of them will work out nicely. Because if we look at x first, well, the top one is 1x. Well, I can easily turn it into 5x by multiplying it by 5, or 4x by multiplying it by 4. If we look at y, well, we have two equations where y has 1 in front of it just by itself, so those would eliminate out already. And I could multiply either one of those by 5 to get it to be the same. And lastly, z. The top one is 1z. I can multiply it by 3 to get 3z, or 5 to get 5z. So in this case, there isn't one that's easier than any of the others. So which one do we want to eliminate first? X, y, or z? X. And since we're eliminating x first, we're going to use the top equation as our eliminator equation, because it's the only one that has 1x to it. So it's the easiest to turn into 5x and 4x. So at this point here, we can rewrite the other two equations below it, since we're not going to be using them as part of our eliminator. We're going to be eliminating x out of these two here. And we're using the top equation to remove it from these two equations. Now, if we look at the one on the left, what do we need to multiply 1x by to get it to be 5x? 5. So we're going to multiply the entire top equation by 5. So when we do this multiplication of 5, 5 times x is 5x, plus 5 times y is 5y, and 5 times z is plus 5z, is equal to 5 times 2 is. Now we're going to put this equation underneath our one on the left. Questions on this so far? Now at this point here, we want the x's to be eliminated from both equations. So we look at 5x and 5x. Would we need to add or subtract them to become 0? Well, we could try subtracting first. 5x minus 5x, 5 minus 5 is 0. So we would subtract. If the signs are the same, we subtract. If the signs are opposite, we're going to add. So let's work from left to right. So 5x minus 5x, as we said, is 0. 5 minus 5 is 0, so we have 0x. We can just leave it out. Our next one, 5y minus 5y. 5 minus 5 is, well, 0. So it cancels out, simplifies out. 5z minus 5z is 0. Okay. Since the entire left side of this equation became 0, we'll put in 0. If one of the variables was left, we would put it. Now I need to look at on the other side. 3 minus 10 is 7, and it would be, is 0 equal to negative 7? Is that a true statement? Well, no. So this here is no solution, and we are finished. Because if we get a statement like this here, a false statement, then it's going to be no solution and we're done. It doesn't matter what the other side does. Because what that is saying is that these two are parallel to each other. They will never cross, they will never intersect. So it's going to be no solution. The other two our equation 1 and equation 3 could intersect at some point or line, most likely a line, but it's not going to matter because the third plane does not cross it. So it's no solution. Questions on any of this here? We good with this one here? All right. Let's look at the next one. Again, we're looking at this here, X, Y, and Z, all of those are good possibilities because there is one variable with one in front of it, so we can easily turn it into the other two. Which one do we want to eliminate first, X, Y, or Z? X. We need to pick an eliminator equation. Do we want to use equation 1 or equation 2? Because it doesn't matter which one we pick from 1 and 2 because both of them have 1 in front of X. So it'll work out nicely. Now the other two equations, we can write them down because we're going to use the middle equation, equation 2, to eliminate X from the other two. Any questions on this so far? Now, for this point, we're wanting to eliminate X. Well, the one on the left already has 1X, and our equation we're using to eliminate it has 1X. So we don't have to do anything to it, which means we can just rewrite our eliminator equation right underneath it because the X's already have the same number in front of it, and incidentally, they already have the same sign. Now, since the signs in front of X are the same, would we add or subtract? Subtract. Or subtract all the way across because X minus X is indeed 0. 1 minus 1 is indeed 0. Our middle one, negative Y minus negative Y. Negative, negative makes a plus, which is indeed 0. Well, this is kind of going the way the last one went, didn't it? Let's look at the next one. Z minus negative Z. Well, the negative negative makes a. So Z plus Z is equal to negative negative makes a plus. So negative 3 plus 3 is 0. So we have 2Z is equal to 0. At this point here, we can solve for Z. We can divide both sides by 2, telling us Z is equal to 0. All right, let's look at the other equation. What do we need to multiply our eliminator equation by to get our X to be 5X? It would be 5. We're going to take the entire equation and multiply both sides by 5. And if we distribute the 5 here, 5 times X is 5X. Minus 5 times Y is 5Y. And 5 times Z is 5Z. And we'll have our sign, so it's going to be 5X minus 5Y minus 5Z is equal to negative 3 times 5 is, and it would be negative. And again, to get X to cancel out, we would subtract. 5X minus 5X is 0. Negative 5y minus negative 5y is 0. And z minus negative 5z, negative negative makes a plus, gives us negative 15 minus negative 15 is, well, z is 0. This here works out to actually be all real solutions. Because we do just get one variable, all we get is z, which means the other variables are going to end up being just on the line y equals x minus 3. Or, well, yeah, y equals x plus 3. It's all real solutions. Because if we end up with one variable, or we get 0 equals 0, it ends up being all real solutions. I'm going to show you this one more time. I'm just going to, you guys can watch it. I'm going to eliminate z first this time. And I'm just going to use the bottom equation as the eliminator equation. Because if I eliminate it from the top one, we would subtract again. X minus 5x is negative 4x. Negative y minus negative 5y. Negative negative make it plus. We'd have plus 4y. Z minus z would cancel. Negative 3 minus negative 15 would end up being 12. So it's a little bit different. 5x. Yeah, not plus. 5x minus 5y plus z equals negative 15. And we'd have the middle equation, x minus y minus z equals negative 3. But this time we would add because the signs in front of z are opposite. X plus 5x is 6x. Negative y plus negative 5y is negative. These will cancel and give us negative 18. Make sure I'm doing this right. Yep. Minus negative 3, yes. Yep. Yeah. Now, unfortunately, at this point here, we've got to multiply both equations by something to get them to be the same. And to do that, it actually works out that we need to multiply the left one by 3 and the right one by 2. It'll make more sense when we do this, because if I multiply this by 3, 3 times negative 4x is negative 12x. 3 times 4y is plus 12y is equal to 3 times 12 is 36. If we multiply the other one by 2, we get 12x minus 12y is equal to negative 36. Now I can put the equations over the top of each other. Let me. There we go. Put those away. And if we do our last elimination step, because the signs are opposite, we would add negative 12x plus 12x is 0. 12y plus negative 12y is 0. So that entire left side became negative 36 plus 36 is, we get our all real. So in either case, we get all real solutions. Questions on this here? All right. Let's look at some more of these here. This one here will actually have solutions, unlike the last two. But we'll look at this here. So looking at this one here, which variable would we eliminate first? X, Y, or Z? And which one of the three would we use as the eliminator equation? The third one, the bottom. Okay. There we go. That's our eliminator equation. Now, part of the reason I highlighted is just to remind myself that's the one we're going to eliminate x out with. And the other two are going to be the ones that we are removing x from. Now, the one on the left, well, we already have 1 in front of x, so we don't have to do anything to it. Even though the signs are opposite, that's fine. We just need the numbers to be the same. Now, would we add or subtract them? Add to get the x's to eliminate. Because if the signs are opposite, we add. X plus negative x, 1 plus negative 1. 1 minus 1 is 0, so those cancel. Then we move on to the next one, negative 2y plus 2y, 0. And lastly, z plus 4z is negative 11 plus negative 9 is because we're adding two negatives together, so we'll get a bigger negative. And you can always plug those into the calculator because there's nothing wrong with doing that, just making sure we get the correct number. And last but not least, well, how many variables do we have left on the left-hand side? Solve for it. So we would divide both sides by almost, it would be negative 4. Well, we have one part of our solution, yes? Now, on the last one, we got 0, and then we ended up solving for the other side, and we also got 0. We only got z, so there's a good chance that's all real solutions. So here, we'll do the same thing. We just need to make sure that on the other side, we just don't get z equals negative 4. Because if we don't get that, then there's an actual solution. If we do, then it's all real. So the first thing we need to do is to get our negative x plus 2y plus 4z equals negative 9 to have the same number in front of x. So what would we need to multiply our x by to get it to be 3x? We need to multiply it by 3. So we're multiplying the left and right side of this equation by 3 to get the numbers in front of x to be the same. So our 3 times negative x is negative 3x. 3 times 2y is going to be plus 6y. And 3 times 4z is going to be plus 12z is equal to negative 9 times 3 is negative 27. And we'll put this underneath. Negative 3x plus 6y plus 12z is equal to negative 27. Blue already. I'll use blue again. Would we add or subtract these to get the x's to cancel? Add, because the signs are opposite, and we can double check it. 3x plus negative 3x. 3x minus 3x. 0. So they cancel out. And we'll add all the way across. 2y plus 6y is 2 plus 6 is 8. So we have 8y. Negative z plus 12z. Almost. Almost. Because negative 1 plus 12, 12 minus 1. Yeah. 12 minus 1, 11. And lastly, 7 plus negative 27 is going to be negative 20. This time, how many variables do we have? 2, yes? Do we know one of those 2? Well, I know z is. So I have one of those 2 values, don't I? So we can solve it. I can take 8y plus 11 times negative 4 is equal to negative 20. If we'd gotten 2 equations with 2 variables, we'd pick one of those to eliminate and go from there. Here, since we already know what one of the 2 is, we can solve for it. So we can do 11 times negative 4, which is negative 44. At this point here, we can add 44 to both sides, telling us that 8y is equal to 24. Because negative 20 plus 44 is going to be 24. And last but not least, we would divide by 8. So y is 3. Any questions on how we found the value of y and the value of z? Now we just need to find the value of x. And to do that, we can pick one of our original equations. Now we pick the top or the bottom. Top. X minus 2y plus z is equal to negative 11. We still have x, because we don't know its value, minus 2 times y. Well, the value of y in this case is 3. Plus negative 4 for z is negative 11. So we plug in the value of y and z. Now we solve for x. Well, our negative 2 times 3 would be negative 6. Plus negative 4 just minus 4 is equal to negative 11. Now we can combine like terms. Negative 6 minus 4 would be negative 10. And at this point here, we can add 10 to both sides, telling us x is negative 1. Which means our solution for this is the point negative 1, 3, 4. Negative 4. Negative 1, 3, negative 4. It is the point where they intersect in the solution for this here. Questions on any of this here? We ready for the next one? Okay. For this one here, we need to pick a variable to eliminate first. X, Y, or Z. Because we have to pick one. Yeah. So we can pick y first. And we'll use the top equation because 1y is going to be easier to turn into 2y and 4y than the other way around. So we can list the other 2 equations first. So we can say 3x plus 2y plus z is equal to 0. And 4x plus 4y minus 4z is equal to negative 2. Now for the left-hand equation, we need to turn our 1y into 2y, and we can do that by multiplying the equation by 2. So we do 2 times our x plus y minus z is equal to negative 1 times 2. So we distribute the 2. 2 times x is going to be 2x. 2 times y is going to be plus 2y. And lastly, 2 times negative z is going to be negative 2z. On the other side of the equal sign, -1 times 2 is going to be -2. So we have 2x plus 2y minus 2z is equal to -2. Questions on how we got to this point here? Now, will we add or subtract these two equations from each other? We would subtract. Because we want the y's to cancel, so 2y minus 2y, 2 minus 2 would indeed be 0. They would cancel. Now we need to subtract all the rest. 3x minus 2x is going to be 1x. Our 2y's minus 2y is 0, y is gone. And our last one, z minus -2z. Well, our negative make a plus. So z plus 2z is plus 3z is equal to 0 minus -2. The minus and negative makes plus. So 0 plus 2 is 2. All right. -1. Now we need to multiply our top equation by a number so that our y's match with the other one. This time we're not multiplying it by 2. We're going to multiply it by 4. So if we distribute the 4, 4 times x is going to be 4x. Plus 4 times y is 4y. Minus 4 times z is 4z is equal to -4. So we multiplied everything by 4, we get this here. And again, just like with our other equation, we can put it underneath. 4x plus 4y minus 4z is equal to -4. And again, we're wanting to cancel the y's out. We have positive 4y and positive 4y. So would we add the two or subtract them? We would subtract, because 4y minus 4y, or 4 minus 4, is indeed 0. So they would cancel. Let's look at the rest of them. 4x minus 4x is 0. 4 minus 4 is 0. Y is already canceled out. Our -4z minus -4z. Well, the negative and negative would make a plus, telling us we have -4 plus 4, or 4 minus 4, which is also 0. So the entire left side of the equation became, leaving us with -2 minus -4, or -2 plus 4, or 4 minus 2, which is 0 equal to a true statement? No. So this here is a what? And we're done. The other two equations do intersect at the line x plus 3z equals 2, or x is equal to -3z plus 2. But because the other plane does not intersect one of the other two, it is a no solution. And that is it. That's all we're going to cover in this here. And we are done with 1.5.